Hello class, want to start with part 2 of our lectures, simple lipids. Yes, so what are simple lipids? Yes, what are simple lipids? We define simple lipids as esters that fatty acids form with various alcohols. So like earlier on explained, fatty acids react with glycerol or any alcohol to form simple lipids. Complex lipids are esters made up of fatty acids, alcohol, and other chemical compounds. Later we look at derived lipids also. So over here we have, let's explain what a simple lipid is. So CH3, CH2, 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 CH2 plus alcohol. Alcohol is represented as what? COH. Okay, so let me erase this shortly. Let me erase this. Okay, so let me erase this one too. Okay, so then C double bond OH plus ethanol. Ethanol is alcohol with 2 carbons. OH. So this CH3. So this one will form C double bond O minus C double bond O minus O, then R. This is R. So I'm representing this, the R on the fatty acid as this. Then the R on the alcohol as this. So those which the substituents that are going to react are C double bond O minus COOH and OH. So the carboxylic acid group, this one, will react with OH to form what? This structure. So this structure over here is an ester. So this is an ester. Sister ester. Okay, so let's go back to our PowerPoint. So a simple lipid are esters that fatty acids form with various alcohol, like what I explained on the whiteboard. Complex lipid is just esters made up of fatty acids and alcohol, but in this time, at this moment, we add other chemical compounds to it. It can be hydroxide group, it can be a metal group, it can be a phosphate group. Then we look at derived lipids. So we classify lipids as simple lipids, that's simple fats and oil, waxes. Then compound lipids are phospholipids, and the phospholipids, they mediate the lipid bilayer of the plasma membrane. So we have the lecithin, cephalin, plasmalogen, sphingomyelin. We also have glycolipids. These are lipids that have been conjugated with what? Glycogen or glucose. So we have, or sugars. So we have cerebrosides, gangliosides. Sulfolipids are lipids that we've conjugated or attached or married it with sulfur. So we have sulfolipids. We have derived lipids also from alcohol, and derived lipids are produced most of the time. The body produces its own derived lipids joining different fatty acids, alcohol, and others to form the sex steroids, which are testosterone, progesterone, estrogen, that mediate the menstrual cycle and male and female infertility or fertility. We also have the isoprenoids, terpenoids, carotenoids for vision or for the vision in the rods and cones of the eye. Okay. So simple lipids are fats, oils, and waxes. Fats and oils are esters of fatty acids and glycerol. The glycerol over here is fatty acids joining with glycerol will give us triglycerol, as we saw earlier on. Waxes are esters of fatty acids and higher molecular weight monohydric alcohols. So we have simple lipids like this. We have the glycerol backbone, and this is the glycerol backbone, CH2O, CH2O, CH2O. Then we have the glycerol backbone CH2, 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 because water has been removed. So we have the acyl group, that's the carboxylic acid group here, and the R group. So we have 1 acyl, 2 acyl, 3 acyl. So we have triacyl glycerol, and this is the glycerol with water has been removed. So H2O has been removed, leaving this OO. Okay, simple lipids. An oil is any non-polar chemical substance that is a viscous liquid at ambient or ordinary temperature, and is both hydrophobic and hydrophilic. Oils have a high carbon and hydrogen content and are usually flammable and surface active. That's why oil is flammable. That's why we can put oil in lamp. Those of you didn't come and meet those local lamps that we use in the villages. You people are technology children. We put oil inside and it will burn throughout the night. Most oils are unsaturated lipids that are liquid at room temperature. So most of the fried oil and others, they are unsaturated. But if you take the meat, the fat from the meat, they are saturated. They are very bad. The fried oil and the rest, they are plant-based oils. So they are unsaturated. They have a lot of double bonds. Simple lipids. The body uses fat as a fuel source, and fat is the major storage form of energy in the body. Fat also has many other important functions in the body, and a moderate amount is needed in the diet for good health. Waxes are esters of fatty acids. A wax is a simple lipid which is an ester of a long-chain alcohol and a fatty acid. The alcohol may contain from 12 to 32 carbon atoms. So waxes are what? Also simple lipids. Waxes are found in nature as coatings on leaves and stems. Please, if you want to know what a wax is, look at the candle. The candle, the white thing which the thread goes through and supports it. That white candle is a wax. If you look at TZ also, TZ looks like a wax because it's thick. So that's how wax is. The wax prevents the plant from losing excessive amount of water. So wax have been coating leaves and stems of plants to prevent them from losing water. So examples of waxes, please go and learn this. Carnauba wax, produced by leaves of Brazilian wax palm, triaconityl hexadecanoate. Okay, so go and look at beeswax also. Formation of ester linkage in a wax. So this is how ester is formed, like I demonstrated earlier on. You see? So the carboxylic acid group will react with what? This OH. And when they react, they release what? Water. So water is released to form this product. So this OH will react with this OH to produce water. And this one will also react with this one to produce this ester group, which is a monoacyl glycerol. So here we have the OH here and the OH here reacting to form water. Then it will be left with this one, this alkyl group plus the carbonyl group, and the 1O, because this H will react with this OH to form water. So it will be left with this O. So this O is over here. Then this CH2 29 CH3 will come and join to the O over here to form this ester bond. Formation of ester linkage in a wax. So look at Carnauba wax. This is the fatty acid that it has. It has what? The fatty acid is what? A 26 carbon fatty acid. Then the alcohol it uses is what? This alcohol. Beeswax also, this is it. Sperm acetic, this is it. So this is what I demonstrated earlier on, how an ester is formed for the synthesis of Carnauba wax. So we have H here and the OH here forming water. So it will have this CO and this 1O to form ester group, and this is the bond. Complex lipids are phospholipids, glycolipids, glycosphingolipids, sulfolipids, aminolipids. Phospholipids are a class of lipids whose molecule has a hydrophilic head containing a phosphate group and two hydrophobic tails derived from fatty acids joined by glycerol molecule. This is what comprises the cell membrane. The phosphate group can be modified with simple organic molecules such as choline, ethanolamine, or ethanolamine, or serine. So let's look at a phospholipid. So this is a phospholipid. This is a long fatty acid chain. This is another long fatty acid chain, but this one is unsaturated fatty acid because there is a double bond. And this is a saturated fatty acid, no bond. So you can see over here, you remember your fatty acid structure. Okay, so this is called hydrophobic tails because it's afraid of water. So these ones are afraid of water, the fatty acids. Then we have the phospholipid group or the phosphate group. This is the phosphate group. It's not phospholipid group, it's a phosphate group. And the phosphate group is hydrophilic because it is charged. Anytime you see a phosphate, it's negatively charged. That's why you can see a negative sign here. This is a negative sign. So it's a phosphate group. We also have the glycerol because you cannot form a phospholipid or any triacylglycerol without a glycerol backbone. So this is the glycerol backbone, CH2O, CHO, CH2. But the other O has been joined to phosphate to form phospholipid. So if this O or this CHO has been joined to another fatty acid like this, so that the fatty acids will be 3 over here, then one will be here, one will be here, one will be here. then we can call it a triacylglycerol. But instead of one fatty acid is missing here from this C, one fatty acid is missing. It has been replaced with a phosphate group. So we have what? Phospholipid. Glycolipids are lipids with a carbohydrate attached by a glycosidic covalent bond. Their role is to maintain the stability of the cell membrane and to facilitate cellular recognition. And this is crucial to the immune response and in connections that allow cells to connect one to another. It means that when the glycolipid is joined to a lipid molecule, then it will aid for cell recognition, meaning antibodies can be able to recognize this glycolipid and bind to it and destroy disease-causing organisms. Or a cell can recognize another cell, or cytokines produced by one cell can be able to allow another cell like neutrophil to recognize the other cell. So we have sugar residue. So glycolipid is here. So we are going to explain glycolipid. So this is a sugar. That's why we say glucose or carbohydrate. So glucose or sugar. This is the lipid bilayer, lipid membrane or lipid bilayer. So lipid joining to glucose form a glycolipid. Glycosphingolipids are a subtype of glycolipids containing the amino alcohol sphingosine. They may be considered as sphingolipids with an attached carbohydrate. Glycosphingolipids are a group of lipids, more specifically sphingolipids, and are part of cell membrane. So let's look at the structure. So this is glycosphingolipids. So we have the cerebroside, we have the sphingosine. This whole structure is sphingosine. The whole structure is sphingosine, and we have the fatty acid here. We have the glucose. So there should be a sphingosine here. Then there should be a sugar, that's the galactose. Then there should be a fatty acid to qualify as a glycosphingolipids. And the sphingosine over here is called what? The structure, the full structure is a cerebroside. So galactocerebroside is a glycosphingolipid. So this is an example, a clear example of a glycosphingolipid. We have the galactosyl ceramide. So we have the glucose structure here. We have the ceramide. So this is what glucose joining to, and this is the two fatty acid chain. One is unsaturated, one is saturated. Then we have the sphingosine. So galactoceramide or oligoglycosyl ceramides, forming an acidic sphingoglycosyl ceramide. We have different types. Okay, let's go to sulfolipids. Sulfolipids are a class of lipids which possess a sulfur-containing functional group. An abundant sulfolipid is sulfoquinovosyl diacylglycerol, which is composed of a glycoside of sulfoquinovose and diacylglycerol. In plants, sulfoquinovosyl diacylglycerides are important members of the sulfur cycle. So let's look at it. We have sulfate. We have the sulfate group here. This is the sulfate group, SO3 minus. And it is joined to what? It is joined to alpha sulfoquinovose. This is a sulfoquinovose. So when you see it over here, sulfoquinovose. This is a fatty acid. And fatty acid is also called acylglycerol. This is a fatty acid. So acylglycerol. And this is a glycerol group. Glycerol group. So this is acyl group. Fatty acid is called acyl group. Another acyl group. And this is the glycerol group. And this is the sulfoquinovose group. So when we add a lipase will cleave off one fatty acid. So one is gone, this one is gone. So we have it is replaced with OH. Another lipase will cleave off this one to remain OH. Then we can also cleave off the what do we call it, when we cleave off the glycerol group, we get the sulfoquinovos using sulfoquinovosides. The sulfoquinovoside can mutarotate. Mutarotate means that it will change its conformation. So aminolipids are described as surface active molecules containing several amino acids and one or two fatty acids produced by bacteria. Aminolipids are considered to be any lipid that has an amino group quotation. So these are all aminolipids. Why is it amino? Because it contains amino acid, serine, ornithine, tyrosine, glycine, leucine. All these joining to dopamine also contains amino group. Serotonin also contains amino group. They are called catecholamines. They are joined to lipids to form aminolipids. Precursor lipids are compounds produced when simple and complex lipids are hydrolyzed or broken down to produce fatty acids, glycerol, and other alcohols. And derived lipids are formed by metabolic transformation of fatty acids to steroids, ketone bodies, lipids. So I've explained this already. Precursor lipids. So these are examples of precursor lipids. Precursor lipids. Lipids that can be hydrolyzed either by heat, alkaline, or acid solutions. Lipids that can be hydrolyzed by either by heat, alkaline, or acid solution are saponifiable lipids. The hydrolyzed products usually include fatty acids. When you break down a saponifiable lipid, you get fatty acids, the source of fatty acids, or fatty acids joined with a salt, then glycerol, and in some cases other molecular components contained in the lipid. So let me explain what a salt or fatty acid means. So if you have a fatty acid like this, Na plus, this is a salt because the H has left. So if maybe you reacted with sodium chloride, if you reacted with sodium chloride, then we have COO Na plus HCl. Let me clean this. So this is what we are going to have. So the sodium will come and replace the hydrogen. Then chloride, the hydrogen will go and join to the chloride, and sodium will come and join over here to form this. So this is a salt. This whole structure is a fatty acid salt, and this is a fatty acid. This R we are seeing here is the alkyl group. The hydrolyzed products usually include fatty acids, the source of fatty acid, glycerol, in some cases, other molecular components contained in the lipid. Non-saponifiable lipids are those lipids that cannot be broken down. Examples include terpenes, steroids like progesterone, estrogen, testosterone, fat-soluble vitamins. We cannot break them down. Saponification of triacylglycerides or triglycerides. How do we break it down? Saponification is just breaking it down, or a process of making a soap. So we want to saponification the process of producing soap. So we want to break this structure. This is a triacylglycerol. This is an acyl group, acyl group, acyl group. Then we have the carboxylic acid side chain. Hey, we have the glycerol backbone. So when we feed this reaction, this reaction with 3 molecules of sodium hydroxide compounds and add heat, we are going to break off all these 3 fatty acids. So in the end we'll have 3 fatty acids, but the sodium will join like this. This sodium will come and replace this hydrogen to form this structure, and the chlorine will attach to this hydrogen to form HCl. So this is the same reaction over here. The sodium will go and join to this O, and this O, because the sodiums are 3. So we're going to join to O to form 3 molecules of what? Sodium, what do we call ethanoate? Sodium, this is 18 carbons. I mean, I've forgotten the name. So it forms this salt. Then this one will also form this one will form glycerol. You see, glycerol is also 3, C3, H8, O3, because so going to form glycerol. So just the glycerol is only one molecule of glycerol, but the triacylglycerols are 3 over here. So you need 3 molecules of sodium hydroxide to react with it. The soap molecule has a head and a tail. So this is the head of the soap molecule, and it is hydrophilic, and this is the tail. So this is the tail, the fatty acid tail, and the phosphate or sodium group tail. So this is how a soap removes dirt from the skin. Or the boys who don't like bathing, should, in case you bath, you will realize that the soap will go and react with this brown thing, that's the dirt, and will move it. It will attach the lipid group to the dirt, and the polar group will be in contact with the water, which is this blue sea. Then it will move the dirt and take it out. The same way when you are washing your hands, soap, water, this is what will happen. The same process over here. The process continues. Lipid transport. Long chain fatty acids are bound to albumin in the blood, and short chains ones are dissolved in the plasma. So short chain fatty acids are dissolved in the blood, but the long chain fatty acids are bound to albumin. Other lipids are transported in lipoprotein complexes, of which there are several types in the blood plasma with different sizes and compositions. So some bound to albumin, the longer chain and the short chain are dissolved in the plasma. Other lipids are also transported in lipoprotein complexes, of which there are several types in the blood plasma with different sizes and compositions. So we have lipoprotein. This is how a lipid is transported in the blood. It binds to what? Lipoprotein. It travels in the form of a lipoprotein. So inside we have these green balls representing triglycerides or triacylglycerides. We have the protein here. We have the phospholipid here. We have the free cholesterol. We have the cholesterol bound to fatty acids. So free cholesterol is outside, and the cholesterol bound to the fatty acid is here. So cholesterol, whenever you see cholesterol, is yellow because it's a troublesome something. But this protein here is very good. You will understand very soon. So this is LDL is called bad cholesterol. or low density lipoprotein. It is very bad. It goes to the liver to cause a whole lot of problems. Intermediate density lipoprotein is also bad. Very low density lipoprotein is also bad. It's called chylomicrons. But the HDL is very good. We call it good cholesterol, high density lipoprotein, because it contains much of the lipid composition is low, or the cholesterol is low. It contains more proteins, so we call it high density lipoprotein, because protein is heavy than cholesterol and the lipids. So we have the chylomicrons. They contain a lot of triacylglycerol. That's the yellow. The yellow represents triacylglycerol. Then we have cholesterol being blue. So bad cholesterol has a bad low density lipoprotein, which is bad cholesterol, has a lot of cholesterol in the blue. Then the high density has low cholesterol, low triglyceride, but more protein. The protein is the red color. So it is a good cholesterol. But the chylomicron has low cholesterol but high triglyceride and low protein. So it's also bad. The low density lipoprotein is very bad because it has low protein, more cholesterol. So look at this table, the apple, B, and the rest, and see what's happening. Please, this a very quick note. Please try and go through the video over and over again. Then after going through the video over and over again, go back to your slides and read them. All the questions in the exams will be coming from the slides. So make sure you understand. There are application questions, 100 questions. I'll give you some objectives. We are not going to write written again. Objectives and its application. The midterm will be coming very soon. But the midterm is going to cover everything. We are going to do about 3 midterms. And they are going to cover everything. So make sure that every time you are up to date before we start the midterm. Hopefully, maybe next week we may start the midterm. So please prepare in advance. Hold your phones all over. Be walking around and just be listening to the recording. Then go back to your notes. On this note, we'll end the lecture here. Felicia and Abigail, make sure that you log into the attendance book for me, the register, which the lecturer's register. When the lecturer finishes teaching, the register that he has to sign, log in for me so that when I come, I'll come and sign. I'll come on Friday and come and sign. But if I don't come early, you just keep the book. Don't send it to HOD, so that I'll come and sign on Friday, anytime Friday. Thank you very much.